All right, so let's talk about game design and object-oriented programming. Okay, you guys learned the different topics, or at least got initially exposed to them, of polymorphism, inheritance, abstraction, encapsulation. And we're going to start using those. And really what we need to do is we've played around with the idea of having a character that could move in our screen. And we've seen firsthand that kind of starts creating spaghetti code when we want to have it do something and make changes to what our initial design is. So we have to go back and kind of look better at the design to make it so it will better flow. It'll work better for incorporating additional pieces into our game. So the biggest thing is that we need to think of, in terms of our game, what is, that's not what I want, what is something that everything has in common in our game. So if I have, say, I have a game piece on there, like where my player has a position, he has probably a velocity, and we were applying gravity and doing different things, but we have that for the most part. And ultimately, we're also going to end up having some additional things. We're going to end up needing to have, a way to display the player, a way to update the player. We're also going to end up having a couple other things that are kind of built-in variables. So we have player position and velocity, but when we go to do collisions, depending on our game, we might end up having certain things like I might have coins that I'm going to collect, or I'm going to end up hitting enemies, or I might end up running into a person that might be part of my storyline, and you might be kind of like an NPC character. Okay? And so the way that I'm going to kind of design this is going to be a little bit extra to what an infinite platform runner is, but you guys could take this and kind of adapt it to different situations. Okay, so if we do look at, we have the player's position, we have the velocity, we're going to want to know if he's able to collide, and then what would he collide with. So if he collides with, say, a coin, then we want to ultimately collect it. If he collides with an enemy, then we need to get hurt. If he collides with part of our world, like a platform, then we're going to need to deal with that. So there's going to be different parts in our game that will change and different parts that won't change. So like static things like map items or tiles on the floor that I could jump off of, those, we can create them once and they basically stay that way. But we're obviously going to end up having some dynamic things created in our game, okay? When we fire weapons or throw like shooting stars or do any of that stuff, that is basically going to be some type of object in our game. When we have our enemies, our player, if we end up having power-ups or coins or some collectibles, those are also going to be things that are going to be different objects in our game. And really what we need to do is we need to pull apart everything that is common in all of those. So if I look at an enemy will probably end up having a lot of the same things. It's going to end up having a position. It's going to end up having a velocity. We'll probably end up having a display, an update, and could end up having a couple additional things. But we're looking at what is the commonalities. Now let's look at maybe like a coin or a collectible. So a collectible would, in our game, have a position, would have a velocity, even if it's 0, would have a display, and would also have an update. Okay, so we end up having a lot of things that are common in here that I'm writing, which means that we want to introduce the idea of a base class. Okay, so since these all have things in common, we create a base class. And this is where inheritance has its magic, because we can have a base class that the player can inherit from, the enemy could inherit from. So when we talk about that, we're mentioning like the position and velocity might be some, component that everybody ends up having and we can inherit. So we could end up having even multiple classes and just work our way down. We might end up having like a base enemy class that I might end up having, say, a bat, a rat, and whatever else, and that could also be inheriting directly from the enemy class. So maybe there's some health components and different things, different types of attacks, and then we can use this. Now, what that means is that we can ultimately use polymorphism, because I can create the same type of methods, and depending on which enemy that I'm targeting or attacking, it will overwrite those things to make it easier for us. So that's really what we want to kind of see. So what we're doing is we're trying to pull out what those things are. So now that we're kind of thinking about that, let's look in terms of what other stuff we could end up having. Okay, so actually I just want to jump into code to do it. So we have to build a new class, and we're just going to call this 3-1. We'll do a class design, and then ultimately we're going to do FSM development. Okay. Actually, we'll do that as a separate video. Okay. So in this one, we're purely just going to think of what do we need for building these classes. Okay. So we have already played around with player. Let's go ahead and we're going to create a file, and let's call it dynamic.js. Okay, and dynamic.js is going to end up having multiple things in it. So let's go ahead and start adding that. So when we create our sketch, we're going to have to add that dynamic. Remember to make sure your spelling's good. Okay, dynamic is capitalized, class dynamic. Okay. Now, if I'm looking at this as my class, this is like my base class, I'm going to end up having a constructor. Everything's going to end up having a constructor. Okay, and I can pass in what I need. So we mentioned that we have a position. We have a velocity. We're also going to end up having multiple other things, and these things are things that we can pass in. So I'm just going to say position, velocity, and then we're going to have some flags. So let's put this DVM, how about like this? DVM, DVD, and friendly. Okay, so these are going to stand for dynamic versus map. So that'd be like our world, dynamic versus dynamic, and then friendly. And I'll get to those, but let's hurry up and do our position velocity. So this dot position is position. This dot velocity is velocity. Okay, now we're going to say this is dynamic versus map. Okay, and we want to pass in what those values are. So in this case, if our player is a dynamic object, but maybe he's a ghost and I want him to pass through things. Okay, well, I could set this flag as true or false for my dynamic creature, and since I'm inheriting from this, can make it easier in my world to choose not to collide with certain things. So I could go through those platforms. I could be invisible and be kind of behind my world. The other one would be dynamic versus dynamic. Okay, so could that ghost be able to still collect a coin, collect a power up? Could that ghost still end up colliding or interacting with another dynamic object? Okay, so maybe I have my player and my enemy. I want to define if they are able to collide with each other. So having something like this will ultimately make it easier because I could choose to turn on and off things as we are playing our game with different power-ups, and can change the complete functionality of my game. But this is not a bad idea to start for almost any game, choosing how we want to collide with different things. Okay, the friendly one. Ultimately, if I'm colliding with an enemy, then I'm going to get hurt. If I'm colliding with, say, an NPC character and I'm building like an RPG game, then I am not going to get hurt, and that's probably when some type of dialogue would start and I could actually start conversing, maybe purchasing items, that type of stuff. So if I was doing an infinite platform runner and I wanted to like rescue the princess and I collided with the princess at the end of that level before I go into the next one or something to that effect, I could have basically a collide function or an on interaction function that I could build in, and this would help switch back and forth if I should get hurt or benefit. Okay, so those are things that we want for every object. Okay, and then I can create some different functions that I think every object is going to need. Okay, now we talked about an update function and a display function. So we could put an update function, and this could be, and I'm just going to write a comment. How about we'll do a console log so we can see it working. Console log. This is the dynamic update. Okay, and then let's do a display, and we can also log this. This is the dynamic display. Okay, so both of these, the reason why I'm doing this is because ultimately we are going to override these, but we need to know what we're kind of doing with this. All right, so we have created a class. We have created a dynamic object class. We have a position and a velocity. We have the dynamic versus map, dynamic versus dynamic, and friendly. So if I save this, I could go into my sketch and I can create the player. So we could create a player, and the player could be created from that dynamic class. So I could say player equals new dynamic and give it a position. So we could say create vector. Let's do it at the center of our screen just so we see it. Width divided by 2, height divided by 2, and we have a velocity. So let's go ahead and create vector for that, and that's going to be 0, 0. And then we say that we want it to be dynamic first to map, so we could say true, true, and true. He's friendly. All right, so there's my player. Now if I want to display, I can say player dot display. And part of this works because we always use the same type of functions. Okay, so there's my display. Here is my update. So now this is the dynamic display. This is the dynamic update. Okay, now that is pulling from this dynamic creature. So that is doing a base class. Let's now create a different one. And this time we are going to inherit. So let's call it a dynamic object. How about dynamic creature .js? And a dynamic creature is going to be, it's a dynamic object, but it can move around in my world. That has some type of health component. It could be destroyed, all of that type of stuff. So I'm wanting to kind of build that in. Okay, so let's again create this, because if I'm going to create, now this is where the order matters, I'm creating a dynamic creature. The dynamic creature is going to need parts of this dynamic class. So dynamic creature, and then we have here, make sure that we're typing everything right, dynamic creature. Okay, now this is we're saying is basically a part, a child of this base class. Okay, so we have our dynamic class. We're going to end up creating that dynamic creature class, which this is going to end up using all the components of dynamic plus, and anything that we want that's additional to that we can override or create. So ultimately my player is going to be here. Okay, so for us to do this, we do have to kind of establish some terminology. So when we are inheriting or inheritance, we look at whatever something is inheriting from. This would be the base class. This would be what we're inheriting from. We say we're inheriting from a base class. Okay, so that is part of the dynamic. Another way that we end up saying it is that this is the super class and this is the sub class, okay, because it is a subset of this class right here. Okay, so when we actually write it in code, that plays in a lot. Okay, to inherit, we have to use the keyword extends, and then we can inherit all of the stuff that we had from before. So if I'm saying dynamic creature is a part of those dynamic objects, then I say they extends the dynamic. Okay, so now it is a part of everything that is part of dynamic is now a part of dynamic creature. Okay, I still end up having to build this with a constructor. Okay, and this is where it's going to seem a little weird, but everything that I pass in to create a dynamic, I have to pass in to my dynamic creature. So I still have a position, I still have a velocity, I still have the DVD, dynamic versus map, dynamic versus dynamic, and friendly. But now I can have additional things. I can have, let's say, health. I could have max health. I could have attack strength. I could have, armor, weaponry, all that type of stuff. And we're going to start kind of refactoring that as we get it. But let's just leave it right here. We have a couple extra things because now we're a dynamic creature. Oh, how about we have a speed? That would make sense. So how about a speed that we are traveling? And ultimately we could maybe have a jump strength if all of the dynamic creatures are able to jump. But in this case, we're probably not going to end up having that. So that might be something specific to the player. But these are all qualities that we would probably see in our dynamic creatures. Okay, so then what we first need to do, and this is the absolute first thing when you are inheriting from the dynamic, you always got to give the base class or the super class what it needs. So you call super, and then you pass in all those things in the exact same order that they need. So we had position, velocity, DVM, DVD, and friendly. Okay, that's what the dynamic class, our ancestor that we inherited from, needs. And then we can put all of our stuff in here. So we can say this dot health is whatever health we pass in. This dot max health is whatever health we pass in. Or maybe we could just set it directly in here. Maybe I wanted to do whatever the health is times 2. That's the max health. Or whatever the health is. And actually, I'm just going to take that off. We'll say that our max health actually becomes whatever that health is. That way, And why did I do this? Is because if we end up healing our player, we don't want to heal them higher than that max health unless we specifically raise that health. So if you're at 75% health and you pick up a potion or some healing thing, a med kit, and it is trying to heal more than your full health, then we need it just to cap out. So we want to create this. So we got health, max health, and then let's do our speed. This dot speed is speed. And now we can still have, so let's save this. Let's come back to our sketch. Okay, player is now not going to be a dynamic. It's going to be a dynamic creature. Okay, and now notice I haven't changed this at all. We're passing in our position, our velocity, DVM, DVD, friendly, health is 100, and speed is, let's say, 5. Okay, now if I run this, what do we see? We still see the dynamic display and the dynamic update. Okay. Also, I have console.log. I have for the player, I now have a health component, so I could see that. So I'm going to run this real quick and then stop it because this is going a lot. Already missed it. There it is, 100. Okay, that was the health that we put in. Let me comment that out. We also have a speed because now the player is a dynamic creature that is inheriting from the dynamic. So I still have all those values. I now have speed and health. I also have max health that I could test for. So let's look at that one. But it's still right now pulling from the same values. There it is. Same values as the update and display. Okay, but I don't have to. So maybe my so here's my constructor. I'm going to say, well, instead of doing my update, so I can write this a couple different ways. So let's just do an update like this. I can, on my update, call the update class. So I could update for my dynamic creature and then also do the updates for my dynamic. So we could play around with this. So we could say console.log. This is the dynamic creature update. Okay. Let's run this, see where we're at. So I want to show this. Okay. Before it was saying it was from the dynamic class, but now since we got the dynamic creature, we're also pulling a part of that. So see, this is now showing the update for the dynamic creature. But I can still pull, I could still say, use the super keyword, and it's always pulling what it's inheriting from. And I could call that update. And now we see the dynamic update for the parent class, and then the dynamic creature update for the child class. Okay, so this is very, very powerful because we can start polling stuff. We've seen that when we just write the same function, that is where we are inheriting and overriding values. Because I can say, well, you know what, my update for my dynamic creature is not going to be exactly the same as my update for the dynamic. And I can do different stuff. We already seen that. Or I want to do additional stuff. So I can play with that. So in this, let's say that I wanted to display, and as long as I'm calling it the exact same name, I can override those previous values if I want to be more specific. So maybe I might have a circle that is drawn at, and everything is still there. I can still access all the original values of dynamic. So I can say this dot position dot x, this dot position dot y. I can say give it a size. So let's just, for right now, we'll just give it a size of 50. If I run this, now I have to call it to be able to see it, but if I call here, now I'm calling the display, I am displaying the dynamic creature display, not the dynamic display. Okay, I could call both of them if I'm calling the super in there. Okay, so this now adds additional functionality. If I wanted to have a multiplayer game and I have multiple players and they all have certain qualities and attributes, I would probably have an additional class for a player that would inherit from the dynamic creature, and then when I create player 1, player 2, player 8, I can use that template to build everything, and it makes everything much more clean. Okay, so this is for moving creatures, but what about if we have, say, collectibles? Well, collectibles will probably still, power-ups, those things will probably still be inheriting from the dynamic, because they're still going to have a position, velocity, dynamic versus map, dynamic versus dynamic, and friendly. So I could create another class and inherit from dynamic directly, and maybe that's going to be a collectible class. I could do this also with, say, teleports, sensors, all of those things. If I wanted to step on a plate or have to jump on a plate to be able to open a door, or I wanted to have a block that when I jump on top of it, it launches me into the air and it's like a spring. Okay, those may not be moving, but they still have a position or velocity. They're still going to end up having these flags, and then I can extend out the functionality of that. So let's go ahead and create another one, and we're going to call it collectible.js, and this collectible is going to end up needing to inherit from dynamic, so it's got to be done on after dynamic was loaded. And collectible. So I have created that. Now let's build it out. Class collectible extends dynamic. Okay, so now I can still do a constructor. I'm still going to need to have that position, the velocity, the DVM, DVD, and friendly. And I'm still going to end up having to pass that into its parent class. So I just write these. I'm just going to copy the rest of them. Okay, and I can think of anything additional that I would need for the collectible, like what it's going to do. Now, if I think about collectibles, if I'm collecting a power-up, if I'm collecting a health potion, if I'm collecting a coin, I might want to have some function that all of them do. So the dynamic one, technically, if I end up colliding with it, I could have some type of interaction. So let's go ahead and add that to the dynamic. So we have an update, we have a display. Let's go ahead and add on interaction. And I might end up passing requirements for there, but this is what I would ultimately override. If I'm interacting with a enemy, and maybe we might call this something else, interact. Now, I can specifically call interact everywhere on every object, but with that I could override and call maybe something specific, which ultimately makes it easy because I could build in my system an engine that when an enemy collides with the player, the enemy knows what to do, the player knows what to do. Maybe I have some type of pushback with the player, and then the enemy, if he was the one that was hit first, I am having him lose health, or I'm having the player lose health, or if I'm collecting a collectible, I need the player to gain some health or collect that collectible, and then I need that collectible to disappear. So I would have an interact with pretty much every object. But collectibles might be more specific. So I might have, with that collectible, I still would probably end up having some type of update, some type of display if I needed, and I could have that be specifically for that dynamic class, or I could make this more specific for like what I'm doing right now. So I could say the interact might actually call something else, like how about apply effect, and I can pass in some effect. So this might be a value, or it might be an object. Okay, and so I can say this dot effect is effect. And we may end up changing this a little bit, but if I want to call that here, I can call that effect. So I could take this, now I could take this and I could say, well, what do they interact with? Find out that dynamic object and then apply that effect to them. So there's lots of things that we could do with how we're doing this. Now, a power-up might be a type of collectible that has specific values and stuff like that. So I might be inheriting, again, from collectible and building this out. So when I'm looking at my sketch, I could have a player, I can have a collectible. Let's say we call it a coin. The coin could still be a new collectible, and we can have, let's say, almost the exact same values, but I want it to be at 0, how about 20? And if I wanted to have it move, I could have it move. I'm going to say that it is not reacting with the map, but it would react with a player. It is friendly. It has no speed, so 0. It has no health. Oops, so I don't even need those things in there, right? Because I'm doing this. Now this is all that I have, but I need some type of effect. Maybe my effect is what? Maybe it is, adding a value like plus 100 or plus 1. So I want to add something to my stuff, okay? So I can do that. Now if I call my coin dot update, let's see what we're looking at. And I want to comment out these. This is the dynamic update, okay? Now, usually when we're doing these dynamic, we probably are going to pass in a name for every single thing. Collectibles will, have a specific name. Enemies will have specific names. Even if I have different types of enemies, I'm going to want to have a specific name. That way I can choose even more granularly how I want to react. So I might override, refactor this and put a type. And if I do that, this dot type is type, and I could even put a name if I wanted it to. Now everything is going to have that, so that means that dynamic creature is going to end up having a type that I got to pass in. The collectible is going to have a type that I got to pass in because now I changed the superclass. So everything has to meet those requirements. Now here, when I create, I'm going to say the player is a player. I'm going to say the collectible is a coin. And now here for this, instead of, like for my collectibles, I have my update. Let's go ahead and write an update here. So we're going to just override everything. Update, and I'm going to console log. And I'm going to do this dot type. Okay. Now I'm in the collectible, but that type exists as part of my object. Okay. Now if I'm in the dynamic creature, I'm also going to do an update. And instead of saying this here, I'm going to say this dot, how about I am a this dot type. Okay, they each have their own thing of what they do. So now if we look here at our sketch, and this is kind of where I'm wrapping up, player dot update. Let's see what they all say. I'm a player, I am a coin. Or how about we rewrite that a little bit with the update for collectible. Collected. No, let's do this dot effect. There we go. Okay. So collected. They each are going to do their own little thing. Now, if we run, I am a player, I collected 1 coin. So we have, with inheritance, created a whole bunch of possibilities of what stuff we did without actually really writing a lot of code. Our player already knows what to do for its update. Our coin already knows what to do for its update. So even though I'm calling that same function, I'm overriding the basic dynamic class or the basic dynamic creature class to what I really needed it to do and make it very, very specific. Okay, this becomes really powerful when we start having more objects, and we can basically loop through all of them and say, hey, update everything, display everything, interact with everything, and then just have it magically work. Okay, that's it. Work on this, write the collectible, write the dynamic creature, and then we are going to start doing more player design before we move farther on this. Good luck, have fun.